For an aerospace engineer, every day begins with the thrill of working on machines that defy gravity, push the limits of human innovation, and explore the mysteries of the skies and beyond. Whether they're designing a new spacecraft, improving the aerodynamics of a jet, or working on satellite systems, aerospace engineers are constantly at the cutting edge of technology, science, and discovery. Their work may not always be glamorous, but it's the kind of job that fuels the imagination of dreamers young and old. That's aerospace engineering, a profession that merges science fiction dreams with real-world science and technology. From crafting sleek new airplanes to building spacecraft that will one day reach distant planets, aerospace engineers are responsible for pushing the boundaries of what humans can achieve in the skies and beyond. Take a moment to think about what these engineers do. They're the minds behind airplanes, rockets, satellites, and spacecraft, the vehicles that connect our world, defend our nations, and help us explore the farthest reaches of space. The history of aerospace engineering is filled with incredible achievements, from the Wright brothers' first powered flight in 1903 to the Apollo missions that put humans on the moon in 1969. Aerospace engineers today are building on that legacy, creating the next generation of flying machines and space vehicles. Today might be a day focused on fine-tuning the wing design of a new commercial jetliner, ensuring that it's as fuel efficient as possible. Or maybe it's a day spent testing rocket propulsion systems, determining if a new fuel mixture can help launch a satellite more efficiently into orbit. Each day is different, but every task is part of the bigger picture, making flight safer, faster, and more sustainable. Many aerospace engineers constantly check the latest developments in their field. Aerospace engineering is constantly evolving, with new materials, technologies, and discoveries being made all the time. Staying on top of the latest trends is crucial, whether it's learning about advancements in aerodynamics or studying how artificial intelligence is changing the way we design spacecraft. Aerospace engineers know that in a field where innovation is everything, knowledge is power. One famous historical figure who knew this well was Sir George Cayley, often called the father of aviation. Back in the early 19th century, Cayley was the first to identify the four aerodynamic forces: lift, thrust, drag, and weight, that govern flight. His work laid the foundation for all modern flight. Today's aerospace engineers continue in his footsteps, constantly finding new ways to manipulate those forces to create more efficient and faster aircraft. Collaboration is a big part of the job. Whether they're working with other engineers, physicists, or computer scientists, aerospace projects require teamwork. They'll discuss designs, run simulations, and brainstorm solutions to problems that come up. Maybe the landing gear on a new plane isn't retracting as smoothly as it should, or a spacecraft's heat shield needs to withstand higher temperatures than expected during re-entry. Aerospace engineers are problem solvers at heart, and they thrive on tackling these challenges. Most aerospace engineers spend a good chunk of their day working with specialized software, like computer-aided design, CAD, programs, to create blueprints and models of the aircraft or spacecraft they're developing. These digital models allow engineers to test different variables, like how wind flows over a plane's wings or how a rocket's fuel burns during liftoff, before anything is built in real life. This saves time, money, and materials, allowing engineers to troubleshoot potential issues long before construction begins. For an aerospace engineer, seeing a design come to life is one of the most exciting parts of the job. One engineer, who worked on NASA's Mars Curiosity rover, recalled the day the spacecraft finally landed on Mars in 2012. "It was surreal," they said. "We had spent years designing and testing every component, and to see it actually land on another planet and start sending back data, there are no words for that feeling." The work of aerospace engineers isn't just about creating new technology, though. It's also about making sure that technology is safe. For example, when designing a passenger plane, aerospace engineers need to make sure that the wings can withstand turbulent weather, the engines won't overheat, and the materials used can handle extreme altitudes and temperature changes. This is where testing comes in. Let's take a look at a typical day in the life of an aerospace engineer, a job that combines creativity, precision, and a love for the unknown. The day often starts in a lab or office, surrounded by computer monitors displaying complex simulations and designs. Aerospace engineers use advanced software to model how aircraft or spacecraft will perform. These simulations allow them to see how a design might behave in real-world conditions without having to build a full-scale prototype. Imagine simulating an entire rocket launch, complete with gravitational forces, atmospheric conditions, and even the effects of space travel, all on a computer screen. Once the engineers have reviewed their simulations, it's time to collaborate. Aerospace engineering is a team effort. Whether they're working for NASA, Boeing, SpaceX, or another aerospace company, engineers regularly meet with colleagues from different disciplines: mechanical engineers, materials scientists, software developers, and more. The goal is to make sure every piece of the puzzle fits perfectly. One tiny error could have catastrophic results, so attention to detail is paramount. There's an old saying in aerospace: a small mistake on the ground could be a disaster in the air. Every calculation, every design choice, and every material must be tested and retested to ensure it's safe, reliable, and efficient. Consider the story of the Mars Climate Orbiter, a NASA mission in 1999 that was meant to study Mars's atmosphere. The spacecraft was lost because one team used metric units while another team used imperial units, causing a navigation error that sent the orbiter crashing into Mars. It's an anecdote aerospace engineers often reflect on, emphasizing the importance of precision and communication in their work. In an industry where success and failure can be separated by millimeters or milliseconds, there's no room for shortcuts. One of the most exciting parts of the day for an aerospace engineer is testing. Depending on the project, testing could involve anything from wind tunnel experiments to launching scale models into the sky. Engineers might be on site at a testing facility, watching a new engine run at full throttle or overseeing a plane's wings being subjected to extreme stress tests. These tests can be exhilarating, especially when months of hard work come down to a few critical moments. Will the design hold up under pressure? Will the engine fire successfully? Will the prototype fly as expected? There's a famous moment in aerospace history that exemplifies the highs and lows of testing. In 1967, during a pre-launch test for the Apollo 1 mission, a cabin fire tragically killed all 3 astronauts aboard the spacecraft. The incident shook NASA and the aerospace community to its core, leading to an intense investigation and redesign of the spacecraft. Aerospace engineers learned invaluable lessons from that tragedy, making safety an even greater priority in future missions. Just 2 years later, in 1969, aerospace engineers and astronauts worked together to successfully land humans on the Moon with Apollo 11, fulfilling one of humanity's greatest dreams. After testing, aerospace engineers spend part of their day analyzing the data they've collected. Did the tests meet expectations? Are there areas for improvement? Aerospace engineering is an iterative process. Engineers must be willing to revise, refine, and sometimes completely overhaul their designs based on the data they receive. It's a job that requires both patience and persistence. As one engineer famously said, failure is not the opposite of success, it's part of the process. One modern challenge that aerospace engineers face is the drive to make aircraft and spacecraft more sustainable. With climate change and environmental concerns on the rise, engineers are focusing on creating more fuel-efficient engines, lighter materials, and cleaner energy sources. For example, there's been significant research into electric planes and hybrid propulsion systems, which could reduce carbon emissions in the aviation industry. NASA is also experimenting with designs that would allow aircraft to fly at supersonic speeds without creating disruptive sonic booms, opening the door to faster, more efficient air travel. But aerospace engineers aren't just looking at the skies, they're looking beyond them. The future of space exploration is incredibly exciting, with engineers playing a central role in missions to the Moon, Mars, and even farther. SpaceX, for instance, is working on the Starship spacecraft, designed to carry humans to Mars. The challenges here are immense. How do you build a spacecraft that can withstand the harsh conditions of space travel and land safely on another planet? Aerospace engineers are solving these problems every day, inching us closer to a future where interplanetary travel could be a reality. There is a possibility that an aerospace engineer might head to a wind tunnel, a giant facility where models of planes or spacecraft are subjected to high-speed winds to test how they'll perform in the air. Wind tunnels simulate real-life conditions, allowing engineers to see how their designs react under pressure. This step is critical because no matter how advanced computer simulations get, there's nothing quite like putting a physical model to the test. Wind tunnels have played a key role in some of history's greatest aerospace achievements. During World War II, they were used to test the P-51 Mustang, one of the most iconic fighter planes of the era. The Mustang's incredible speed and maneuverability were due in large part to wind tunnel tests that helped engineers fine-tune its aerodynamic shape. In addition to these activities, aerospace engineers might turn their attention to writing reports or presenting their findings to stakeholders. Whether it's for a commercial airline company or a space agency like NASA, clear communication is crucial in this field. Engineers need to explain their designs, outline the risks, and propose solutions in a way that's understandable to non-engineers. It's one thing to know how to build a rocket, it's another to explain to a board of directors why your design is the best one for the mission. There's also the growing field of satellite technology. Aerospace engineers are developing smaller, more powerful satellites that can be used for everything from GPS navigation to climate monitoring. These satellites provide critical data about our planet, helping scientists study everything from weather patterns to deforestation. With companies like SpaceX and Amazon investing heavily in satellite networks, the world of aerospace engineering is expanding faster than ever before. Of course, not every day goes smoothly. Aerospace engineering is full of setbacks, and part of the job is learning to embrace failure as a stepping stone to success. Failure is an option here, said Elon Musk, founder of SpaceX, after one of the company's early rocket crashes. If things are not failing, you are not innovating enough. Aerospace engineers know that failures are part of the process. Each failed test, each redesign, is an opportunity to learn and improve. It's what makes the eventual successes, like SpaceX's Falcon Heavy rocket, which successfully launched in 2018 after years of trial and error, even sweeter. As the day wraps up, an aerospace engineer might take a moment to reflect on the bigger picture. Every calculation, every test, every design is part of something much larger, whether it's making air travel more efficient and environmentally friendly or helping humanity explore the farthest reaches of space. The work of an aerospace engineer is, quite literally, shaping the future. There's a quote by aviator Charles Lindbergh that captures the spirit of aerospace engineering: science, freedom, beauty, adventure. What more could you ask of life? Aerospace engineers get to live that quote every day. They work at the intersection of cutting-edge technology and boundless imagination, making the impossible possible, one flight at a time. Whether they're designing the next generation of supersonic jets, working on spacecraft to explore the moons of Jupiter, or figuring out how to reduce the environmental impact of air travel, aerospace engineers are always looking toward the future. And while the job is filled with technical challenges and long hours, it's also filled with the knowledge that they're playing a key role in humanity's greatest adventures, on Earth and beyond. By the end of the day, an aerospace engineer might find themselves looking back at their work with a sense of pride. Whether they've been working on the next generation of commercial aircraft, exploring cutting-edge space technology, or developing more sustainable aviation solutions, their contributions are helping shape the future of transportation, communication, and exploration. Aerospace engineers are dreamers who make those dreams come true through hard work, creativity, and precision. As they look to the future, the sky is not the limit, it's just the beginning. As the legendary rocket scientist Wernher von Braun once said, "I have learned to use the word impossible with the greatest caution." For aerospace engineers, the impossible is simply another challenge to overcome. And with that mindset, every day in the life of an aerospace engineer is an opportunity to push the boundaries of what humanity can achieve, whether it's soaring through the atmosphere or reaching for the stars.